Happy New Year, PlayBASIC coders. Let's take a look at something. A bit of progress has been made with the math libraries. Here's a ray tracer, version 4. Now you've seen the potential visibility set stuff. We'll see how this captures. It's running all right, capturing, but not great. That's standard ray trace mode. You can turn the shadows off with F3. Add more objects, etc. That's weird. Just happened to be where we're sitting. Right, that's a classic mode. That's the way it was running before. It was firing out rays for every pixel, comparing every pixel against every single sphere in the world. Yeah, that's not that useful, is it? Not a good idea. Now PBS mode is what we added last time, and we're talking about where the world is broken down into small subsets of objects that are within each subsection of the screen. So we have an initial list of impacts that is generally pretty low. So even when you have lots of objects, and we're going to test that in a second. Turn that off. It's pretty distracting. So I've got 50 objects there, no shadows. We'll put the shadows back on. No, we'll bump it up first. And you might have seen last time that we could get, a few hundred objects and that would choke. Well, welcome to the new reality. Complete software. This is not compiled native. It's not GPU. It's not threaded. We're still running on the legacy PlayBASIC runtime, PlayBASIC 1, right? Now it's a low resolution, granted, and we're not really modeling light here. We're just doing array of sections against a bunch of spheres, and we can turn shadows back on. And this is the crazy part, is that it still actually runs pretty well, comparatively. If you're not sure about that stuff, what actually happens is that the ray, each pixel has two sets of ray intersections happening with it. So we have, for each object, we have a list of objects that run from the viewer. What's easy to see here, actually it's not easy to see there. You see up here it's saying in this space up here there's one object. So in that case there, that square or rectangle, I think it actually is, only has one ray intersection to worry about. If I turn brute force mode back on, we're back into this. It takes a long time to refresh. So it's night and day, and the way this has been possible is that I've just moved some of the problem back from the user side of the equation back into the engine side. So I've added, rather than having a rated sphere, which you can still do, that's all fine, you can give it a list of spheres and then it runs off and finds the nearest impact on that list. And the same for shadowing as well. So we turn shadows off. Now here's something crazy. I don't know what that's running at. We're still in the teens. 17 frames per second, which is, I wouldn't have thought that was possible at all. I thought, my original thoughts of this, I thought maybe we can get like 10 frames per second for maybe two objects on screen or something like that. Nothing like this. So the threshold has been bumped up. We'll probably get an array out of bounds here at some point because the caches I've created are a fixed size. What are we up to now? 1500 spheres? No shadows, of course. Put the shadows back on, see how we go. Now at this point here, I think really the density of the scene is actually helping us occlude other objects. So we're actually missing a bunch of those things. What's interesting is it makes it look more impressive. The more objects you have, even though the rates, probably down to, 5 frames or something. So look, oh no, about 9 apparently. We're capturing this thing on my little laptop here, so it's no brute force horsepower machine. How old is this thing? It's about 10 years old. Let's bump up until it errors. See how far we get. 1600 objects. I think it's capped at 2000 now. I haven't tried this, by the way, that's why I'm curious to see if it will work. Yeah, that's the threshold. I think we can probably go further than that, actually. Sounds crazy, but we can probably go further. Let's try something insane. Completely insane. We'll go back to half the resolution. Brute force mode. Enable PBS mode. Now, I don't think this will make much difference in here. Turn shadows off for a second. I'm just curious about how well this would work if we bump the object count up a lot higher. Turn shadows off. With each shadow, I think I was trying to explain this before, the shadows are pretty much binary. So we have a list of objects between the object that a ray impacts with and the light. There's only one light in the scene. It doesn't actually, the pixels aren't lit based on the light either. So it's not really doing, we're kind of cheating with most of this stuff. It's designed as a ray intersection test rather than a ray tracer per se, but it is ray tracing the scene. So we definitely couldn't do that before. My only worry about the new commands is that you have to make a list of the items you wanted to search. That they're a little bit lower level than what people might be expecting. But anyway, that's pretty good. I wasn't expecting it to work that well. Surely it'll crash soon. I don't know, she's running, running well. We'll turn shadows on. Yeah, we were in slideshow territory, but before, scenes with only like 100 objects at this resolution were taking over a second to render. So this has made a big difference. And really what we're talking about actually in the longer scheme of things is getting used to this idea of batching up jobs to do and then passing off the job to something else. This is not threaded, as I said before. It's not hardware accelerated at all actually. We don't have any special instruction sets. We're not using any of that stuff. It's just really it's a design pattern that we're trying out. We're just trying to go, what if we just solve the problem better than what we were before? And that's what we're doing. And by doing that, we've identified that we can have commands built in which are very small that do a lot of the brute force for us. They when each ray is fired out into the world, we have a short list of objects to test. And the only time there would ever be thousands of objects to test would be if they are all in a row from that point. Imagine standing down a wall or something like that, where that wall is comprised of thousands of spheres, all of one size or whatever. If you stood in front of the wall, then it's probably going to be a bunch of individual ray intersections, but on the edge of the wall and look down it, that's where you would end up with rays being compared with thousands of objects potentially. Pretty crazy stuff. Alright dudes, thanks for listening. See you next time. Onwards and upwards.